All right, today we're going to be working on a problem-solving strategy, writing an equation. You're going to want to use this strategy when you have a formula that's already set up for that type of problem, or when you want to write equations to solve numbers that include numbers that are written in scientific notation. It really helps to have an equation written out with scientific notation, specifically because it can get confusing with how the number looks when it's in that form. So we're going to do two examples today in the video about how to use writing an equation um, when solving a word problem that has to do with scientific notation. All right. So the first one says a space probe traveling at about 2 times 10 to the fourth power miles per hour takes 760 days to reach Jupiter. Find the distance the probe travels. Now, a couple things about this. You know the rate. We know the time. And we want to know the distance. All right. So there's a specific formula, actually, that goes along with distance, rate, and time. Its distance equals the rate times time. All right, so before we even start plugging things in, there's one thing we do need to notice. If you haven't already caught this, you probably will now. If you notice, our time is in days, but our rate is in hours. So we actually need to convert our days to hours. So first, before we even plug things into our equation, we're going to say 760 times 24. And the reason we're multiplying it by 24 is because there's 24 hours in a day. And we want to go from hour days to how many hours. So 760 times 24 is, and I already did the math for you, it's 18,240. Now, from there, we can plug it into this distance equals rate times time formula. We can say distance, which is what we're trying to find, equals the rate 2 times 10 to the fourth power multiplied by the 18,240. All right, so as you know from learning about multiplying scientific notation, we are going to multiply this 18,240 by 2, and that's going to give us 36,480. All right, and that's going to be times 10 to the fourth power. Now, as we know, this is not correct scientific notation, so we need to put that in correct scientific notation, which is going to bring us to 3.648. And because I moved the decimal point over 1, 2, 3, 4 times, my exponent is going to become 8. So how far does it travel? It travels 3.648 times 10 to the 8th power miles. All right, so it's that easy. All right, so this next one deals with the same type of idea. So sound travels at about 1.1 times 10 to the third power feet per second. How far does sound travel in 11 seconds? Okay, so we can use that same distance equals rate times time formula. And you're going to notice that we don't have to do any converting because our problem has already set up the distances in the correct way. We have feet per second and seconds. We don't have to convert anything. So we have our distance, which is what we're trying to find, equals our rate, which is 1.1 times 10 to the third power, and that's multiplied by 11 seconds. So we multiply 11 times 1.1, and that equals 12.1 times 10 to the third power, and putting that in correct scientific notation, we have 1.21 times 10, because we moved it over 1, to the fourth power, and that is feet. All right, so that's all it is. So in your WISC tonight, I would like you to do these two problems. They are pretty self-explanatory. They work with just writing out an equation for your problem. Please make sure you bring any questions or concerns you have to class the next time we have class. And otherwise, have a good evening.